Hi, my name is Josh Julak. I'm a Principal Security Solutions Architect with AWS. And this is SEC 203, AWS Identity, choosing the right mix of AWS IAM policies for scale. Today we'll be looking at 4 common IAM policies within AWS across 2 policy categories. We'll then be choosing the right policy mix across 6 common use cases that we see customers have. We'll then look at some high-level operational aspects of interacting with those policies for validation and monitoring. But be aware that we won't be going too deep. This is a 200-level talk. So why does this matter? Well, John Culkin, a professor at Fordham University, said, "We shape our tools, and thereafter they shape us." And I think this quote summarizes it pretty well. When I think of AWS IAM policies, I think of it as a set of tools that we can use. And so the point of this talk is to make sure that you understand how to shape your tools wisely to enable your business to have agility later on. So primarily there's 2 policy category types. We have guardrails and we have grants. Now guardrails set the maximum permissions for your accounts or your environment. Well, grants are the policies that actually give permission. So I can have a bunch of guardrails that actually allow permissions, but if I don't have grants that grant the permissions, then the permissions are denied for the principal. So really, we want both. We want grants and we want guardrails. And we'll take a look at what that means. So today we'll be looking at 4 core types of policies. And be aware that there are other policy types, but those are more advanced and out of scope for this talk. But these are the more common ones, and so we'll be diving into these a little bit deeper. So we have organization SCPs and IAM permission boundaries. And those are both guardrail types of policies. On the grant side, we have identity-based policies and resource-based policies. Now, rather than just defining these 2 types of categories and their policies, we'll be defining them in the context of use cases. Now, before we pick an example customer and those 6 use cases, I want to point out that we have millions of AWS customers across every vertical and industry facing their own unique challenges. I've worked with startups that are building their first cloud-native application, and I've worked with enterprises who are going all in on AWS. And so we realize that every cloud journey is unique, and so you may need to adjust some of the recommendations or use cases that we present here and fit those to your particular scenario for your organization. And so with that in mind, let's look at our first example corporation. So this is Example Corp. They're a pretty large enterprise organization with hundreds of internal and consumer-facing applications. And they have dev teams that write the code for these applications. And they have operators that manage the applications as well in the systems that they're on. Now, recently, Example Corp has been migrating to the cloud to enable business agility and to save cost. And at the heart of all their cloud services is identity and access management. So it's important to Example Corp to choose the right mix of identity and access management policies to fit their use cases. And this is where some of the core teams come in. Now, many AWS customers I work with have several centralized teams, such as a cloud platform team, a security team, and an identity and access management team. And these teams divide responsibilities from writing policies to implementing code and peer reviewing each other's policies and work. So you might be wondering, do I have all these teams within my organization? And perhaps you have more, perhaps you have less. And so again, remember that you might need to take some of the recommendations here and alter them to fit your specific organization. All right, now that we've established our business scenario, let's look at how to choose the right policy mix across those 6 primary use cases I mentioned. So these are the 6 use cases for Example Corp. They're going to want multi-account guardrails. They're then going to need baseline account automation to set some governance and security checks in place. Then they want to federate their users, and so they'll need baseline human access to their environments. And those users are going to be building applications, and they need to give access to the applications And so that's our fourth use case of machine roles for applications. And we want to make sure that there's appropriate guardrails in place for when they're creating those policies. So we're going to also have a use case of bounding the maximum permissions that developers can create. And then we'll be looking at resource permissions and cross-account access. So for our first use case, we have multi-account guardrails. Now, Example Corp has dozens of AWS accounts, and they need a way to structure them. And so they chose AWS organizations to help here. In the management account of AWS organizations, Example Corp can use that to create new AWS accounts and to set up governance in place as well. One of the mechanisms they can use is called organizational units, and that allows them to structure their accounts in a hierarchy. And they can have multiple organizational units, or OUs as we often call them. And then in terms of guardrails, Example Corp is going to leverage something called service control policies, or SCPs. Now, these SCPs set the maximum available permissions for accounts, organizational units, or the entire organization from a centralized place. So what are some examples of service control policies that Example Corp can use? Well, service control policies enforce what we call security invariants. And security invariants are essentially conditions that you want to always be true. So what are some examples of security invariants? Well, two examples are you might want to deny access to API operations in accounts or regions that you don't use, right? And so you could deny that access to regions outside of your normal use case. The second example would be to prevent non-administrator users from disabling configurations such as logging. So those are two common security invariants that we see customers leverage security control policies for. So let's dive a little bit deeper into the use case number one for multi-account guardrails. So we chose to use service control policies because that enables us to put a governance in place across multiple accounts. Now, service control policies are categorized as a guardrail type of policy, and they would be managed by one of those central teams that we talked about before. It could be the cloud platform team, the identity team, or a security team. But of course, we want another team to peer review that team's work for separation of duties. And so when that team is crafting these service control policies, another centralized team can peer review that work. Now, they would be deployed via the organization management account, so be aware that it is deployed from a centralized location at the top of the organizational AWS organizations account, the management account. And it would be applied to the entire organization, an OU, or an account. And you can have multiple service control policies, so keep that in mind. And you can structure them appropriately based on your business requirements. Okay, so let's move on to our second use case. Our use case number two is baseline account automation. Now, a common practice for many of our customers is to provision some common baseline resources into every AWS account. This could be S3 buckets, it could be logging configurations, or it could be automation like Lambda functions. Now, if you're not familiar with Lambda functions, they're essentially a service that enables you to execute code either an event-based or schedule-based. So customers often use them for security checks. Now, it doesn't have to be Lambda functions. It could be EC2 or Fargate even. But let's take the example of Lambda functions. And we want to deploy these Lambda functions to implement some security checks in each AWS account that we have. But the Lambda functions themselves don't have permissions, so we need to give them permissions. And the way we do that is we assign them a role, represented here by the red hard hat. And the role doesn't have permissions either, so we have to create a policy, an identity policy document that we attach to the role in order to enable permissions. So here you'll see that we have Lambda functions, roles, and policies that we would be deploying into each AWS account within our organization. Now, to actually make that happen, you could use any type of automation that you have or want to leverage. But if you don't know where to start, you might consider CloudFormation stack sets. Now let's zoom into just one of those accounts. I mentioned we'd be deploying Lambda functions into these accounts. And so here is a more appropriate example where we might have multiple Lambda functions, and they're each trying to solve a different use case. You can see the arrows here that are indicating that these Lambda functions are interacting or checking on different resources. And so they're each performing a different task. And the principle of least privilege tells us to authorize the minimum set of permissions necessary for each principal or each Lambda function. And so we want to give each of these Lambda functions their own different unique role. And so with that, we also want to create an identity policy for each role as well, in order to have separation of duties and a principle of least privilege for each of those Lambda functions. And again, we can deploy these through CloudFormation stack sets or some other automation mechanism. Okay, so let's dive a little bit deeper into our second use case. So for baseline account automation, we chose to use identity policies because our goal is to enable platform automation. Now, identity policies are categorized as a grant. And again, they would be managed by one of those centralized teams, such as Cloud Platform or the Identity team. And they could be peer-reviewed by another team, such as the Security team. But again, these are illustrations or placeholder examples of those centralized teams. So again, pick the appropriate combination for your individual organization's scenarios and use cases. Now, in terms of actually deploying them, a lot of customers will use what's called an account factory pipeline. And they'll leverage that for deploying these Lambda functions, these roles, and these identity policies into each account. Now, if you don't know much about account factories, I would encourage you to scan this QR code to learn more about how AWS Control Tower can help you get started. All right, and so in our next use case, we want to enable access for Example Corp's employees. And this is baseline human access. And so you can see here at the bottom, we have human users within Example Corp that need to perform activities in the cloud environment. And their roles are different. And so we want to create IAM roles in the AWS accounts that match those responsibilities. So you can see here in the AWS account, represented by the red hard hats, we have an administrator role, a developer role, and a read-only role. Now, we want these cloud users to be able to access the AWS account and get access to those IAM roles using their same employee login information. And how do we do that? Well, we can leverage federation systems in the process of federation to enable access from those users that exist in your environment today to be able to federate into the AWS accounts and be able to access roles that are appropriate for their specific responsibilities. Now, if you're not familiar with the process of federation or how to set that up in AWS, I would encourage you to scan this QR code for more relevant info on federation. So let's dive a little bit deeper into our third use case of baseline human access. We would leverage identity policies that are applied directly to those individual roles. You'll remember the admin role, the developer role, and the read-only role. Those would have 3 separate identity policies for separation of duties that match the responsibilities of the individual users within your environment today. So this is very similar to the previous example, but rather than being assigned to Lambda functions, we'd be assigning these to principals or roles that humans are going to be accessing. And so we want them to be managed by a centralized team as before, and be peer reviewed by another team. But it's important this time to include the developers as stakeholders into this conversation, because developers are going to be accessing this environment, and so are operators and other teams. And you want to include them in the conversation to understand what kind of access they need to get their jobs done. And that way, you prevent yourself from becoming a business blocker to your cloud migration. Okay, great. So now the Example Corp developers have access to AWS accounts. And so let's just focus on a single example here of developers from your current environment today accessing a developer role through federation. Now, these developers need to build business applications or migrate workloads. And oftentimes you'll see that these developers need the ability to create not just an EC2 instance for compute for their applications, but they also need to give access to those applications. So you'll see that developers are creating EC2 instances with permissions. And the way they do this is through roles and policies. And so that means our fourth use case is giving developers the ability to create roles and policies that they can assign to their EC2 instances. But let's dive a little bit deeper. For our fourth use case of machine roles for applications, we're choosing to use identity policies. And again, this is a grant policy, and we're granting permissions, in this case, to EC2. But our goal is to provide permissions for that infrastructure by empowered developers. And so we're going to let the developers manage and create these policies. They can then deploy them through their own current application pipeline for CI/CD. And they would apply these directly to what we call execution roles, which are just the roles that are assigned to a machine like EC2. Now, what does this asterisk mean? How can we safely empower a developer? Well, I'm glad you asked, because that takes us to our next use case. So for our fifth use case, we want to bound the maximum permissions for these empowered developers. Now, there are hundreds of developers at Example Corp, and we don't want the centralized teams to become a bottleneck here in terms of reviewing or trying to create policies. So the question is, what guardrails can we put into place to allow empowered developers to create new roles and policies on their own safely? And the answer to that question is permissions boundaries. So you can see here, similar to the previous example, we're allowing the developers to create new roles and new policies and assign them to the EC2 instance. But also, in addition to assigning the blue policy that represents the EC2 identity policy, they would also have to create the yellow policy, which is a permission boundary, and assign that to the role as well. Now, this changes the effective permissions of what that EC2 instance can do, because the permission boundary sets the maximum permissions that the entity it's assigned to can have. And so you'll see here that the permissions boundary would be defined by an administrator or a central team, while the IAM identity policy is defined by the developer. And then the intersection between those two policies is what the effective permissions would be. So let's dive a bit deeper into this fifth use case of bounding maximum permissions. We're choosing to use permission boundaries because our goal is to empower developers with guardrails. And so permission boundaries are categorized as a guardrail type of policy. Now, they would be created and managed by a centralized team, like we had talked about before, but they would actually be leveraged by the empowered developers. Now, to actually get the permission boundaries into individual AWS accounts, the centralized team would use the account factory pipeline to deploy them, and then require the empowered developers to leverage them when they're creating their own rules and policies. This removes the bottleneck of a single team having to write every single policy or review every single policy. But it's important to treat the developers as stakeholders here in the conversation of creating these permission boundaries to understand kind of the use cases that the developers are working with and the applications they're building and what access those applications need. Okay, time for our last use case. So previously, we've been talking about assigning permissions directly to identity policies that we attach to principals like roles. But rather than assigning permissions directly to roles, we could assign permissions directly to resources. An example of this is the Amazon S3 bucket, which offers a bucket policy, or the key management service, which offers a key policy. There are two reasons why customers often want to do this. One is it simplifies the number of places you have to look to determine who has access to this resources. But the second more popular use case is to enable cross-account access for another account or principal in that account, either within your organization or perhaps maybe a partner, to access resources in your account. So for example, here we could have another principal, a role from another AWS account, access a object within your S3 bucket. So diving a little bit deeper into our sixth use case of resource permissions, we're leveraging resource policies or resource-based policies to enable these permissions. Now I should note that these policies are generally optional in most cases, and typically the resources are for the specific applications that the developers are building. so that in most cases, they're managed by the developers themselves for their applications or workloads. But it could be managed by a platform team or a centralized team as well for some common baseline resources that are being deployed into each account, such as S3 buckets for collecting logs or SNS topics for notifications. And that would be managed by a centralized team. But in the majority of cases, developers would be deploying resources, perhaps with a resource-based policy attached to them, and they would be deployed through their application pipeline. Great, so that concludes our 6 common use cases. Let's quickly take a look at how we can operationalize these various policy types. So in terms of policy validation, we recommend across the board that you leverage code versioning systems like Git for storing these policies as code. This helps with peer review from other teams who want to inspect and check the policies that you're creating. As teams mature, you can leverage some pipeline checks and automation to ensure that you're not making simple mistakes. And things like linting within a pipeline can help with that. Many organizations are leveraging test organizational units or OUs and test accounts to deploy policies to test them as well and to validate their expectations. And lastly, we offer an organization's access report, which helps validate whether or not services are being used. And this can help when you're writing SCPs to determine whether or not you want to turn services off. In terms of policy monitoring, we recommend using AWS CloudTrail across the board. This helps when you're trying to understand what actions are being leveraged within your accounts and what services are being used, and also to check whether or not policy changes are happening. IAM Access Advisor tells you what services were last used, and this is helpful for tailoring policies as well. Config rules enables you to check periodically if your policies are changing, and EventBridge allows you to trigger automation and event-based when changes happen to your policy. So this is useful for reverting changes or notifying someone that changes are happening. And lastly, the IAM Access Analyzer helps determine if a number of different resource types have been shared with an external entity outside of your account or environment. So in summary, we talked about 2 high-level policy categories, guardrails and grants. On the guardrail side, we talked about organization SCPs and IAM permission boundaries. On the grant side, we talked about identity-based policies and resource-based policies. Now notice 3 use cases that we talked about today leverage identity policies. So that's your primary focus. But remember, you want grants with guardrails in order to have the most secure environment while you're migrating to the cloud. Now there are other types of policies as well, but those are more advanced and beyond the scope of today's talk. So in summary, we talked about the various policy types. We talked about 6 core use cases for example Corp and common use cases that we see that customers are leveraging. And we talked about some high-level operational aspects for validating policies and monitoring policies. Now, if you're looking for more information about IAM, you're in luck. We have several other reInvent sessions that are available for you to watch. Thank you for attending today's session.